This is a demonstration of our PC Lab computer. We have an HP computer running Windows 7 64-bit operating system with 8 gigs of RAM. We're not doing anything right now. We're idling, and we're already using over half of our memory. This presents a problem, which I will demonstrate here in a minute. When we have low physical memory, Windows compensates by using part of the hard drive where your data is stored. These numbers are troublesome already. It's hitting inside that disk every time it's writing. Actually, it's reading, and it's using it as virtual memory. And we'll show that in just a minute. Let me just walk through a normal day. Classes are trained to come in and log in to Edmodo as their class manager. We'll just watch what the memory does as we go through, put it through a couple of things. MIT App Inventor, after spending 6 weeks with MIT Scratch program, learning just a little bit, we're trying out App Inventor. App Inventor creates apps for Android devices. We're going to make it a little easier. Hard fault here on our hard drive. Why? Look what Windows is doing for us here. It's allocated 5 gigabytes of RAM for the hardware. 5/8, whatever percentage that is tied up, not usable to us to run our applications. It's tying up 2 gigabytes on standby because Windows anticipates it thinks it's smarter than us, and it has put that on your side. So the kids today in first period, they downloaded this first so they could make their applications right there on the window and not their phones, and they were to create this application with the help of a tutorial called Ball Bounce. Notice our memory ticks up just a little bit. We're just running the browser. It should be no big deal. We've got a nice sharp image. One thing I like about these computers, we do pretty good on that. It still bothers me. Look what our memory is doing. We're not really doing anything yet. We're going to do some real work here in a minute, and the real world application to do that. The web technology classes have been working on web pages. Now it's time to get serious, and we're going to put several pages together and make an entire website. Every time you see a hard fault, it means that Windows is hitting your disk, your physical disk, and reading it, whatever is there, and committing that charge to virtual memory. We have 5/8 our memory in use tied up, so we're not doing anything. So their assignment today, they were downloading some actual files to practice with, and they have a tutorial that is set up, and by the end of it, they were to have created this nice little web page. So I have a sample of what I would do. I'm going to have to open up our application. I have Creative Cloud already as an individual subscription. I'm going to open up the new version of Dreamweaver, which is a HTML authoring and editing. See what happened when I open the application. Having to compensate here. This number should be down to 20%. There's no reason for it to be up there at 50% other than we don't have enough physical memory installed for this particular configuration system. It's having to work very hard. So I'm going to open up a HTML page that we have started earlier, and I'm going to delete this because I want to make sure that picture is going to be the right size for the page that we have in mind. Golly, look at the hard drive is working way too hard. Again, this is not really taxing work yet for a computer. I want to use Photoshop. because I want to be sure that picture is the right size, and I want to see if I need to do any editing for that. Okay, it should be open by now. Taking its good sweet time. She and I have it home. Run circles around this. And let's take a look at this picture. Let's load up. Okay. Wow. Not too bad. Let's check the size of the picture, make sure it's going to fit in the spot that we have selected for it. Size 600 by 380. That's about right. Okay, I like that. Let's take a look at the image itself and see if we need to do any touch-up. Of course, if you start with a good picture, that's the best way to do it. I've zoomed it way out. Let's save our results. I'm going to move ahead here. Let's save and put it back where it was. Thank you very much, Photoshop. And close that out. Then we'll come back to my application. Here it's opened. Insert. And I'm going to do it the fast way. I'm going to cheat instead of writing code out. I'm just going to use the graphical interface. And again, it's scary where that memory is sitting. I don't have any headroom, any reserve. Let's see what our page is looking like. Let's put it up in the browser. Okay, good. We've got the beginning of a web page. I went to school in Missouri, William Jewell College. Nice private, small school with good ratio, teacher to student ratio. Okay, so that's one example of a day in the life. Let's make sure this gets saved back. And we'll do that. Another thing we do, gamification for education. We researched quite a bit last year, and last year we put in a dedicated server sitting right beside me here, a Mac, a mini Mac, where the most popular game in the universe, Minecraft, has been retooled in an EDU version, and it's a global phenomenon. There are classrooms all over in every language using this, and so we've got math concepts, geometry concepts, science and physics that all go into this game. Let's see if we can make an appearance here, and are we stable? Looks like Windows is treating us okay. No, let's go ahead and point this on in. So Minecraft is really quite amazing. There are a lot of ways to approach this. There are assignments embedded into this. Okay, that throws me up again. That's not supposed to do that. Thank you, Windows. I'm still hovering along here, and it bothers me. This is showing me, again, every time you see a hard fault there, we're getting, oh my, up in the 90s highest activity. Windows is not going to be nice to me today. It's freezing up my game. We really do learn something from that. Every time we see that abnormal thing there, Windows is going in and basically attacking the hard drive, compensating for it wants more memory. The CPU has to work. We did okay with that on our configuration. You can see all this together. And it's just a shame that we should have no more than 20% of this memory dedicated to the operating system function, leaving us a lot of headroom, a lot of extra leeway to do some real intense work. And we're doing work. And we're learning in this lab. And that's what it's all about. So, proposing that we upgrade the memory so that the kids get an experience this year of a quality program.